Okay, hello everyone. So in this video, we'll be looking at another question where we're asked to design a regular expression that describes a language. In this case, the language we're trying to describe contains strings of the alphabet AB, where those strings are the string V, then the string W, then again the string V. So they can be sort of partitioned this way, where there are properties that we insist the strings V and W have. So in particular, V should be a string of size 1, and W should be a string of size at least 1. Okay, so this is exactly 1, and this is at least 1. Right. So let's just look at first of all, let's just look at strings that would sort of match or that would be in this language. So my strings have to essentially start and end with the same letter, right? Because this V is at the beginning and at the end of the string, so it's sort of um, describing what the first and the last part of the string should be. And because the length of V is 1 here, it's saying that that first and that last part is sort of size 1, right? So for instance, let's use the variable u since I'm already using w. I could have a and then a, so at the beginning and at the end, right? They have to be the same because I need v to be the same, right? So here this would work, like v would be equal to a. And then I could also get, w can be any string, but where its length is at least 1, right? So W could be something like BA, right? And so that would work, right? So then I would get something like BA, and this would be W, right? So that would be one possible string. Another possible string might be, well, let's have V is B, and then W is, I don't know, like A, B, A, right? So then in that case, U would be B and then B, and then in the middle, I would have A, B, A, right? And so this can, I can have an infinite number of strings that look like this. But essentially looks like what it looks like is going on here in terms of like the pattern is, well, it's essentially sort of described already a little bit for us in the language, right? We have uh, the first letter is the same as the last letter, right? And then in between, we have to have at least one letter, but there could be more than one, right? So if we think of like a string in general, then it could be either A with some stuff in between and then ends with A, or it could be B with some stuff in between and then B again, right? And then in the middle, right, in the middle, I have to have at least one um, the string W, right, has to have size at least 1. So then it has to have at least one A or B, right? One A or B. And then it can have with possibly more here. So possibly more of the same pattern right next to it, right? So here, and then I could have extra A's or B's. Okay, so now it's shaping up. It looks like my regular expression is going to look like some first part, and then some second part, and then some third part, right? So it looks like my regular expression will be, well, I know the middle has to have, so the middle has to be A plus B. Um, so I have to have at least one A or B, and then I can have any number of A's or B's that follows. It could be 0, it could be 1, 2, or so on, right? So then here I can have any extra number of A's or B's. And then at the beginning, at the end, I have to sort of hard code this idea that I need the same letter, right? So in this case, it would be, A, right? Or it could also be B, the same thing in the middle, and then B, right? So then could we maybe, that seems to be like the pattern if we use a plus or an or in between the two regular expressions. Could we like maybe compress this further, right? So like maybe we could do something like R is A plus B, A plus B, A plus B star, and then A plus B, right? Because I'm saying, oh, well, the beginning is either A or B, and then the end is either A or B, right? So although this seems appealing because, you know, it's shorter and cleaner, this would not be acceptable. So, you know, this works, but this does not work. And the reason why this does not work is because, you know, remember, think of regular expressions as kind of like being different parts of the regular expressions are activated by different parts of a string. So in this case, right, there's no, in this regular expression, there's no constraint that this first thing is the same as the second thing, right? And so this is a theme that will keep coming up when you look at exercises in like theoretical CS stuff. So so that means that I could have the string u is, you know, A, and then maybe some stuff in between, doesn't really matter. And then B, right? Because why? Because, you know, A plus B, well, that sort of allows or explains or enables either A or B. And then again, A plus B, well, that, you know, same idea, enables or describes A or B, so then it could also be B. And then I have stuff in between that gets explained. So then this regular expression describes strings, in particular, you know, this one, but this string is not in the initial language L, right? And so that's a problem because then I would have a false positive, right? So this would count as a false positive. And so for the regular expression to be correct, right? So for a regular expression to be perfectly correct, then it should describe, so R must describe all the strings in L and only all the strings in L. And so that's not happening. So if this is R1 and this is R2, that's not happening in R2. In fact, in R2, what we have is something like the language of R2 is a superset of L, right? So there's stuff in L of R2, which is not in L. And so that's kind of what I mean again by false positive. And so given this, then the regular expression that does work between R1 and R2 would be this one. So I'll just paste it back here and put it in a nice box. Okay. And so this is a regular expression that describes the language L. Maybe you could think of another one. Let us know if you do.